Machine learning. Machine learning, ML, is a subfield of artificial intelligence, AI, that focuses on building algorithms and models that enable computers to learn from data and improve with experience without explicit programming for every task. Here is how the learning process in machines works. 1. Data input. Machine needs data like text, images, or numbers to analyze. Good quality and enough quantity of data are important for effective learning. 2. Algorithms. Algorithms are mathematical methods that help the machine find patterns in data. Different algorithms help different tasks such as classification or regression. 3. Model training. During training, the machine adjusts its internal settings to better predict outcomes. It learns by reducing the difference between its predictions and actual results. 4. Feedback loop. Machine compares its predictions with true outcomes and uses this feedback to correct errors. Techniques like gradient descent help it update and improve. 5. Experience and iteration. Machine repeats training many times with data helps in refining its predictions with each pass. More data and iterations improve accuracy. 6. Evaluation and generalization. Model is tested on unseen data to ensure it performs well on real-world tasks. Machines learn by continuously increasing their understanding through data-driven iterations like how humans learn from experience. Machine learning is important for the following reasons. A. Solving complex business problems. Traditional programming struggles with tasks like language understanding and medical diagnosis. Machine learning learns from data and predicts outcomes easily. B. Handling large volumes of data. The Internet generates huge amounts of data every day. Machine learning processes and analyzes this data quickly by providing valuable insights and real-time predictions. C. Automate repetitive tasks. Machine learning automates time-consuming, repetitive tasks with high accuracy, hence reducing manual work and errors. D. Personalized user experience. Machine learning enhances user experience by tailoring recommendations to individual preferences. It analyzes user behavior to deliver highly relevant content. E. Self-improvement in performance. Machine learning models evolve and improve with more data helps in making them smarter over time. They adapt to user behavior and increase their performance. There are several types of machine learning, each with special characteristics and applications. Some of the main types of machine learning algorithms are as follows. 1. Supervised machine learning. 2. Unsupervised machine learning. 3. Reinforcement learning. Additionally, there is a more specific category called semi-supervised learning and self-supervised learning, which combines elements of both supervised and unsupervised learning. First, let us discuss the supervised machine learning. In supervised machine learning, the machine is trained using labeled data. This means that for every input, the correct output, answer, is already known. You can think of supervised learning as learning under the guidance of a teacher. Imagine a teacher teaching students. The teacher gives questions. The teacher also gives correct answers. Students learn by comparing their answers with the correct ones. Similarly, in supervised learning, input data is given. Correct output, label, is provided. The model learns to map input to output. For example, if an email input contains words, "win a prize," then the email will be labeled as spam. If an email input contains the words, "meeting at 10," then the email will be labeled as not spam. After seeing many such examples, the model can classify new emails. There are two main categories of supervised learning. 1. Classification. Classification predicts categorical outputs, meaning it assigns data into predefined classes like spam or non-spam emails. These algorithms learn to map input features to discrete labels. Here are some classification algorithms. Logistic regression, decision tree, random forest, k-nearest neighbors, naive Bayes, and support vector machine. 2. Regression. Regression predicts output values by identifying linear relationships between real or continuous values, for example, temperature, salary, etc. It learns the relationship between input features and a numerical target variable. Here are some regression algorithms. Linear regression, polynomial regression, ridge regression, lasso regression, decision tree, and random forest. Supervised learning is used in a wide variety of applications, including image, speech, and text processing. For tasks like image classification, speech recognition, and sentiment analysis. Predictive analytics. To forecast sales, customer churn, stock prices, and weather conditions. Recommendation and personalization. Powering systems that suggest products, movies, or content. Healthcare and finance. Used for medical diagnosis, fraud detection, and credit scoring. Automation and control. In autonomous vehicles, manufacturing quality checks, and gaming AI. The next type of machine learning is unsupervised machine learning. Unsupervised learning works with unlabeled data where no correct answers or categories are provided. The model tries to discover hidden patterns or structures on its own. Imagine students are given many books but no teacher. They group books by subject. Identify similarities by themselves. Similarly, unsupervised learning finds structure in data without guidance. For example, given the customer data such as age, income, and buying habits, this model groups customers into different segments without being told what the groups are. There are three main categories of unsupervised learning. 1. Clustering. Clustering is the process of grouping data points into clusters based on their similarity. This technique is useful for identifying patterns and relationships in data without the need for labeled examples. Common techniques include k-means, discan, mean shift. 2. Dimensionality reduction techniques. Dimensionality reduction helps reduce the number of features while preserving important information. Common techniques include principal component analysis, independent component analysis. 3. Association rule learning. Association rule learning is a technique for discovering relationships between items in a dataset. It identifies rules that indicate the presence of one item implies the presence of another item with a specific probability. Common techniques include a priori, FP growth, ECLA. Here are some common applications of unsupervised learning. Clustering and segmentation. Group similar data points, customers, or images. Anomaly detection. Spot unusual patterns or outliers in data. Dimensionality reduction. Simplify large datasets while retaining key information. Recommendation and marketing. Identify user preferences and improve product suggestions. Data preprocessing and analysis. Clean data, detect patterns, and support exploratory data analysis. The third category of machine learning is reinforcement learning. In reinforcement learning, an agent learns by interacting with an environment and receiving rewards or penalties. The goal is to learn the best action to maximize total reward. The agent interacts with the environment, receives feedback in the form of rewards or penalties, and learns optimal actions over time. A simple analogy is how a pet is trained. Correct action implies reward. Wrong action implies no reward or penalty. Over time, the pet learns the best behavior. For example, an AI agent learning to play chess gets positive feedback for good moves and negative for poor ones. Over time, it learns strategies to win more often. The following are the two major types of reinforcement learning. 1. Positive reinforcement. Rewards desired behavior, for example, giving points for correct answers. 2. Negative reinforcement. Removes negative outcomes to encourage good actions, for example, turning off a buzzer after the right move. Some of the most common reinforcement learning algorithms are Q-learning. Learns the best action for each state based on expected rewards. SURSA, state action reward state action similar to Q-learning but updates values for the action actually taken. Deep Q-learning uses neural networks to handle complex state-action relationships. Applications of reinforcement learning include gaming and simulation, teaching agents or non-player characters to play and adapt intelligently. Robotics and automation. Enabling robots to perform tasks autonomously. Autonomous vehicles. Helping self-driving cars make real-time decisions. Healthcare and finance. Optimizing treatment plans, trading and resource allocation. Recommendation and personalization. Improving user experience through adaptive suggestions. Industrial and energy management. Optimizing control systems and energy use. Thank you for watching this video on Introduction to Machine Learning. In the next video of the Generative AI series, we will explore the topic, Deep Learning. Do watch it to continue your learning.